Hello and welcome back to my series where I work through the NeetCode 150 list. Today I'm going to be solving my 69th problem. And this is a lot of problems lighter than my last video because I flew through the backtracking section. It was crazy. I did all the questions like so quickly, which is pretty sick. And yeah, since I was just in such like a flow, I just kind of like grinded them out. And then I did a couple other questions as well to prepare for an interview that I had. But yeah, so today I'm going to be jumping into solving some dynamic programming problems, or a dynamic programming problem. But it'll be the first one that I'm solving on this channel, which is freaking awesome. And also, guys, if you are struggling with dynamic programming, okay, major key, like lock in right now, okay? Solve this list, especially doing like, okay, like of course, like arrays and hashing, 2 pointers, assignment or whatever, but linked list problems and tree problems and backtracking problems are so helpful for dynamic programming problems. And I did not get that, but even though they're like different sort of applications of recursion, learning how to think recursively, which I would not say that I'm an expert at yet, but like just like gaining an intuition for it and like being able to draw out like the recursive tree and everything like that is so helpful. It is so helpful. It has changed the way that I'm able to approach these problems. And like I'm not an expert, I would say yet, but I'll get good at them as I continue to practice. But like before when I would attempt these sorts of problems, I would just be like, sort of like, I guess like lost. Like I wouldn't know how to like approach it. Also, reading the chapter from Introduction to Algorithms by CLRS is has also been very helpful too. So I would highly recommend both of those things. Yeah. Anyway, today we're gonna be solving a problem that I have attempted. It's called longest palindromic substring, and I was not actually successful at solving this problem in the time constraint that I gave myself. So today I'm going to be solving it again, but like properly. Or I'm going to be solving it. I have only seen the solution, I haven't tried to implement it. Um, but yeah, this one's a bit weird because it's not just like the numeric ones, like all of these problems. Those ones are quite easy, I would say, or like a bit more intuitive, but this one's a bit weirder. But yeah, as you can see, I got I submitted a bunch of times, I think. Let me see what I did. Yeah. I've tried it, I guess, a year ago, but I did not remember my solution clearly. But yeah, so I did a recursive method, like a recursive solution, I believe, and that didn't work because of the memory complexity and because of the way that I was doing it. I think was just wrong. But yeah, so I'm going to start off with reading the problem, and then I'll go ahead and jump into OneNote and draw out a solution, and then I will implement it. So this problem statement is really quite simple. It just says, given a string S, return the longest palindromic substring in S. Something to be very careful about when reading these problems, and a mistake that I personally have made, is there is a difference between subsequence and substring. Or like, I don't know, okay, maybe, hold on, let me like fact check myself real quick. Whoops. Okay, yeah, so a subsequence, this is really important, is not the same thing as a substring. So if you ever are given these problems in an interview, please make sure you know the difference and you're carefully like double checking. Because a subsequence, you can remove characters, but a substring, you can't. It has to be like a contiguous, like, it has to be a contiguous a sequence of characters in a string. Like, it can't be missing anything. Okay. Anyway, now that I've made that hopefully very clear, I'm going to move my laptop so I can draw on it. Okay, so here's an example that we're given. And the reason that this one is like a bit weird is because it's, I don't know, to me it doesn't feel like a numeric kind of dynamic programming problem, but oh, anyway. So okay, we have this string BABAD. And I might just change it to a Z because I might get confused with the D. Okay. So we can see here that like this is gonna be nope, not that, sorry. This is gonna be our longest palindrome, or like this is acceptable as well. And okay, so first I'm going to just like draw I guess I should just like go over the really naive solution, which would just be like iterating. Okay, so it's kind of like 2 pointers in a way, like you start from here. Okay, that's a substring, or that's a palindrome. That's not, that is. So now we update our thing, and that's not, and then we can go, okay, like that is, that's not, that's not. Hopefully you can see where I'm going, and this would just be like a nested for loop, and I believe that would have would that be O of n squared or O of n cubed? It would be O of n cubed, because we would have to then like check within each like section if it's a palindrome, and at the worst case that would be O of n time, and so we have to do that O of n squared times, wait, yeah, because we're checking like here, and then we're like iterating O of n, O of n, O of n, O of n, and that we did that n times, and then we're doing it again, O of n, O of n, O of n times, etc., etc. So that would be O of n cubed time. Okay, so what can we do? How can we make that faster? Well, something to be like aware of is, okay, this is a palindrome, just a single letter, and also that's a palindrome, etc. And what else is a palindrome? Well, this is a palindrome because these two letters are the same. And I think actually this problem is a bit easier to understand when you actually just look at something that has all of the same characters. So I'll just go ahead and do these two cases where one of them is going to be even and one of them is going to be odd, just for simplicity. So in the odd case, it's quite easy to understand how this might work. If we just start off in the middle here, we go, okay, well that's a palindrome, and then we can like then look on either side, and we know that if those two characters are the same, then nothing has changed, it's still a palindrome. And we can just continue expanding outwards from this character and checking if it's a palindrome. And we have to do that for each character actually, so like we would need to start from here and look outwards, and then here and look outwards, etc. But it's a little confusing actually when you're starting from here. I guess if you're starting from there, then you can't really, because you're at the boundary of the array, so like you can't look outwards, you can only look forwards, so you don't really want to start there. Okay. Now I'm getting to the point where I don't know this like the solution, because basically the point of making these videos for me is to build an intuition for myself and like build like my own understanding and record that process, as opposed to like teaching per se. But hopefully, like if you learn something from this, then that's awesome. Maybe you're able to like learn from how I approach problems, etc. But yeah, so if my explanation kind of devolves here, it's because I've started actually solving the problem. Okay. And so basically, yeah, so we start to somehow expand. I know that. Like you can update like that. And that would be like doing this is O of n time. Just like continuously checking. And when would we want to stop that? I guess if you start, like the best case scenario would be if you start from the middle and you expand out and you just hit a palindrome like the whole time. Like that's like the longest possible palindrome that you could have. And then if you don't hit a palindrome from that, then you would want to like start searching the other palindromes. So, okay, let's say we have B, or actually let's say we have like something like A, B, 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 Z, Z. Okay. So like we start here, and ideally we want all of these to be B's. That would be like the greatest thing. That would be our longest palindromic substring, and I'm just gonna create a variable called LPS. And so we just start there and we expand out and we go, okay, so first we have a B, and then we notice when we go put 2 pointers out here, those are also B's. And we know that like here is a B, so we can just go ahead and add this to our LPS. And also we'll be saving this, I think, in terms of the index of the array, but for now I'll just keep it as a string because it's just easier to visualize. Okay, and so then we're gonna look, okay, actually what I might do is add some characters so that we end up replacing this. Okay, hopefully this doesn't take too long. But anyway, okay, so now we see, okay, these characters are clearly not the same, so there's no point in expanding outwards anymore. So now what do we do? Well, we could have the case of like, B, 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 A, B, 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 or we could also have the case of B, 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 Z, B, B, B. So what do we do? Well, we're gonna have to search both of those cases. So what will we do? We will set our our pointer over here to where we were, and we'll expand outwards. So maybe actually we do want to start from the side, because that way we can keep track easier. So okay, yeah, let's just go ahead and try that. So let's say we start from here. We can't expand because we are bounded by the left side of the array. So then we're just gonna go ahead and increment. Okay, so now we can expand by 1 on either side, and we see, oh, that's a palindrome, great. So we can just go, and this would be an empty string, by the way. We can go AAA, awesome. And then now we're gonna go from here, and we're gonna expand out. Okay, that's a palindrome. Like, okay, we see this is a palindrome, and then we see this is a palindrome, and then we see that's a palindrome. So now we'll go, awesome. And then we'll go from here, and we'll expand. Oh, these don't equal each other, so we're gonna have to move forward. Okay, so we're now starting from here, and then we expand. And these don't equal each other, so we have to move forward. Here, expand. This doesn't equal each other, we have to move forward. Here, expand. That's a palindrome. It's not longer than what we currently have stored up here, so we just go ahead and move forward. And that's not a palindrome, so we move forward. That's not, because these don't, so we move forward. That is, so we're gonna have to check on either side. It's not, so we move forward again. And now we have this case, where it is not. No, it is. Wait a minute. Okay, so now we have this case. And here we will see, okay, like that is a palindrome, so we check on the outside, and that is not, or that is a palindrome, so we need to check again. Okay, so then there's also going to be the like even odd situation, which I'm not sure exactly how to handle, but you can kind of get the gist. And so how do we keep track of like if something's a palindrome? Well, we can just go ahead and create an array called like isPally, and we'll just go ahead and set everything to false at the start, and maybe I'll just go ahead and make it like FF for false, by the way. F, F, F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 3, 6. Oh. 12. Okay, so now we have an array of false. And what we're gonna do is, if we hit a base case, then we're gonna like want to set that as true. And also we are gonna want to make it either like a 2D array, but I think you can also use a hash map potentially, but I don't know. And the reason that we want a 2D array is because there's two like coordinates to consider. Like there's a left coordinate and the right coordinate, like left index and right index of where the string like starts and ends. The substring, that is. Okay. Alright, so we have this, and now we can go like, this actually feels wrong. Let's think here. Actually, no, this should be okay, because even if one changes the true, as long as like both aren't true. Hold up. this is gonna correspond to the substring 0, 0. And this one would be corresponding to the substring 0, 3. Hold up. What? 3 what? 3. Because wouldn't this be making a 2D grid of size like n by n? Yes, it would. It would. Okay. So we don't want that. Because there's well, okay, no, like that's fine. But yeah, this will make a 2D grid of size n by n, not like this. It'll have to be bigger. It'll be 12 by 12 in this case. And okay, so what I'm gonna do instead of this for visualization purposes is I'm just gonna make this a hash map and hope that it works. And if it doesn't, then you can just think of it as if I'm setting like position ij in a two-dimensional grid as true. But instead, what I'm gonna do is make a hash map where I have coordinates as the key and not coordinates, sorry, a subsequence as a key, and then like if it's a palindrome or not as the value. And initially, I'll just set it like I'll have it be I'll use the .get function, like .get coordinates, and then I'll go like false if it's not in there. No, that won't work. I'll query the dictionary. If the key's not in there, then I'll check if it's a palindrome or not. And if it is, then I'll set it to true, and if it's not, then I'll set it to false. Okay. Okay. So what is our base case? And this is a weird one to think about base cases in, because it's not like, I don't know, it doesn't feel like a normal problem to me, and maybe it's because I don't have like a full grasp on the problem, but like, it's not like I have a bit of a problem thinking about it recursively. But anyway, okay. So our base case is like we either have two things that are the same, or we have one thing that is the same, because we're looking for like symmetry around either 2 or 1 value. So I guess if we were thinking about this recursively, it would be like, okay, we're here, and then we see, okay, there's a B, and we know that's a palindrome, and then we see, I'm thinking of this one, by the way. Let's go B, B, B. So, okay, we see that's a B, and that's a palindrome, and now we can either, like, update with another B, like this, or we can just, end it there, and that would be a palindrome. And then we'd be starting, like, we can skip that B, and then start looking at the next, item, which would be a B. So, like, if we thought about this with, like, ABC, actually, we can either go A or no A, and that would give us an A. And then if we don't pick up the A, then we can then pick up a B or no B, which just gives us an empty string. And then if we have the A, we can pick up a B or no B, A, B. And then we could pick up a C or no C. And same here, we could either get a C, oops, or no C. And same here. And same here. Okay. So these are like our base cases. These levels, because if we have a palindrome at either of these levels, we won't know from like expanding out from the center, because we can't do that for an even sized palindrome or even sized like 2-character string. We have to just like check the letter next to it, and if that's the same character, then we know, okay, now we can start expanding out from here. Okay, so how do we check if we have like an even palindrome? Let me just think real quick about this case. Okay. So like this isn't really actually like helpful. Yeah. Unless hold on, I'm gonna pause real quick. Um okay, I don't think thinking about this as a recursive tree is gonna help me actually. But I would love to see somebody draw out the recursive tree for this problem because I don't I don't get it. Okay, but basically, let's just say we have these two. Okay, like I'm just trying to figure out now where we're starting from. Um, so in this case, if we start here, then we look here, and we see those are the same. Now what? We can't go left, and we can go right, but okay, yeah. So let's say we go up by one. We see that's the same. Oh, we go up by one, it's the same, and then we go up by one, and it's the same. And somehow it's like centered. Right, because we are bounded by the left. So like anything that's the same, it's gonna have to like match that, like as we keep going. Until it doesn't. So like we get here and now okay, that's not the same. So also we're at the very like end of our array, so we can't actually like have a palindrome here. But we could then check like all we know is if this is a palindrome or not. We don't know like the characters, we just know this. So we could have like A, B, B, B. Actually, yeah, let me try that real quick. So, okay, we start here. That's a palindrome. We look and see, okay, these are not equal to each other. And so we could have a palindrome, but because these are palindromes by themselves, and then, okay, actually, what if we like first iterate over, or like, okay, yeah, so we know that all things of length 1 are a palindrome, and then we could check, for all things of like length 2, is that a palindrome? Yes. Like, okay, so we'd have like, what the heck? I honestly think that like the dynamic programming solution to this problem makes no sense. Like expand from the center makes way more sense and it is more space efficient. But like I want to do the dynamic programming solution because I'm trying to learn dynamic programming. Um but like okay, if we start from here, then we know okay, or like okay, we start from here. We can only go one because we're bounded by the left. Here we can only go up to like sorry 0, and then from here we can go 1 because that's our bound. Or once we get to here, then that's greater than length 2. So we could check from here, and if that's the same, then we can move our point to here and start expanding like this. Okay, so that's not a palindrome. And then once we get to here, we can go, okay, that's not the same, but this is. No. Yeah, because then we skip the even case. I'm so confused. If this is the same, and then this is the same, then we know we have a palindrome here. And we want one pointer to be here and one pointer to be here. And then we can look, okay, that's not the same. So we go back, I guess. And that is the same. So now we know that's a palindrome. And then we go out. I'm just confused about like the even odd case. Okay, I might just look at a solution because I am stuck. And why are we starting from the end? That's another thing I don't understand. Okay, so we're starting from the end because we have one pointer going in like this. This is our I pointer. And then when we have the I pointer, then we have our J pointers going out. So it's kind of like a 2 pointers problem, but just like kind of weird. But this is what we're doing by going backwards. So I guess like in that same way, you could have your I pointer start here and your J pointer start here and iterate in, maybe? But then you're starting with like the longest. Okay, the reason you don't want to do that and you want to do this is because this will force you to start with like the shortest strings and build up as opposed to starting with the longest strings and going smaller. And you want to do that because we're like building up, like we want to be able to like set the base case first for each string, like each substring. So like we want to have we want to have 3 equals true before we check 0 3. Okay. I definitely don't think I would have come up with that by myself, but it's okay. That's part of learning, isn't it? Okay. All right. So let's think through this again. Oh yeah, and I wanted to understand how like that worked. So okay, let's make an even case real quick. So we have A, B, B, A. We're starting here. We go, okay, that's a palindrome. We go here. That's not a palindrome. We go here. Well, this wasn't a palindrome, and these don't equal each other. Wait, this wasn't a palindrome. No, we actually are not doing that. We're going here. Okay, so this is our I pointer, and this is our J pointer on the bottom. So we're saying, okay, that is a palindrome, so we'll be setting 3 to true in our hash in our like dynamic programming cache. And then we'll update our I pointer and our J pointer will be here and we'll go 2 is clearly true. And then we'll update our I pointer to this and BA is not a palindrome, so we're gonna keep that false, but that's just implicit, so I'm not gonna put that there. And then we'll go, okay, BA. Okay, so we'll go 1 is true. Now in this case, these two equal each other. So we know that is a palindrome. And that is gonna be 1, 2 is true. And then we'll go here, and that's false still. And then we'll have our I pointer here. And we'll go, okay, 0 is true. 0, 1 is false. 0, 2 is false. But yeah, that's false. Okay, well now we see, okay, we see 3, 3 is true. And we see these two equal each other. Sorry, okay, no. First, we see that these two equal each other, yes. And then we know that this, wait, hold on, I'll leave that there and I'll use a different color. We know that this here is also a palindrome. And since these two equal each other, then we can keep that, or we can set that this is true. We can say now 0, 3 is true. Because that was true, and this is true. Alright. And the reason that we want to set these cases to true is because if we had an odd palindrome like this, and oops, I should let that I and J pointer, so I here, oops, J here, okay, so that's gonna be true. I'll just take the solution off the page as well so I can focus on like getting this in my brain. So okay, we'll go 2, 2 is true. Then we'll go, okay, 1, 1 is true. 1, 2, not true. Then we'll go 0, 0 is true. And then we'll go, okay, well that's not the same. But once we're here, then we know that 1, 1 is true. So therefore it's a palindrome. Okay, I understand, like conceptually, but I don't understand, like mathematically, I would say. But that's okay. I think I'll just bully ChatGPT a little bit later. Okay. Alright, now I'm going to try to implement this. And also, this would be, I believe, O of n squared time complexity because we are checking, like we're having a nested for loop and we're, in the worst case, checking n characters n times, doing a constant time operation, which is checking the cache. And the thing that we're speeding up here also, like the thing that we're caching is, like our brute force way would be is if we had like an is palindrome method and we were like here and we'd go, okay, well these two characters are the same, so now we just need to check are these inner characters the same. And we would do that using like is palindrome that index. Oh, this is actually so close to what I did yesterday, now that I'm thinking about it. I did come up with a brute force approach, but what I was doing was I was starting from the left side, iterating out, so that wasn't going to really do me any favors because I wasn't limiting like the search in that way. Like I wasn't setting my base cases. And I had the is palindrome method checking in between like each two index. And what I was doing is I was storing the result from is palindrome in a cache, and then I was using that to like I guess I was trying to do a top-down solution, sort of like this. This was my solution from yesterday. So like basically I was doing like a DFS and I was trying to like basically prune these branches here where like the same thing would get checked multiple times. But it didn't end up working because of the memory complexity. And I think that is maybe because it was recursive, but I can't be sure. Okay. Anyway. Let's think. Okay, so now I also for myself I have the OneNote screen like I'm not looking at it, and I do this so that I can like logically understand the code. So we know that we're gonna have a cache, and it's gonna have to be a 2D array. Um, okay, I'm actually not sure if that's correct, but what the heck? Yeah, okay, it's not. It needs to be like this, I think. Yeah, because then we'll have in list, it's like in falses and in lists. Okay, so then we go for I in range S. No, we want to start from the end. And it's gonna bring us down for J and range I S. So this is gonna bring us up from where we are. Now we want to do if Si equals Sj. So like if we see two characters that are the same, then we want to check is everything else inside of them also a palindrome. And if it is, then we want to set that index in the cache to true. So if those are the same, and either we have our base case, so j minus I is less than or equal to 2. So we either have hold on, plus 1. That's just for readability, but actually it's not really that readable. But because of zero indexing in Python, you might have like 0, 1, as in like the index 0 and the index 1, and 1 minus 0 is 1, but clearly there's two characters there. So that's why you add 1. Or so that's our base cases. Or cache I plus 1 j minus 1 equals true. Then we want to set cache I j to true. And then we'll keep LPS as a index if j minus I plus 1 is greater than or equal to LPS 0, 1 minus LPS 0 plus 1. LPS equals IJ. Return S LPS 0 plus 1 plus 1. Okay, I think this should work. Nope, missing out a closing parenthesis. What? Uh-oh. Okay, sweet. So it does work on the test cases. We'll see if it passes. Awesome. Yeah, so there are faster ways to do this. There's an algorithm called like Manica's algorithm or something like that. But like I said, and there's also an O of 1 time complexity way to do this too. But the reason that I solved it in the dynamic programming way is because I want to practice dynamic programming. Not necessarily because that's the optimal way to solve this problem. And yeah, hopefully if I was in an interview this would work, but I think that I would be able to get the expander on the center method. But yeah, so thank you for watching. This was one of those ones where I wasn't able to get it just by myself, but I was able to build up my understanding for sure, and now I definitely like see where all of it's coming from. Although the only thing that I don't quite get is how to like make this a recursive problem. Actually, I do get how to make it a recursive problem. I'm just gonna write that out really quickly, just like for fun. because this is a bottom-up approach, because we are starting at each index from size 0, like from just one character, and we're building up like a cache of all of the results. I'm not totally sure about doing a top-down approach, how to do that, but I think that if I were to write a recursive algorithm for this, I would just start with, I guess I can write it in LeetCode. I'll reset this. So I'd go def helper, and what would I do here? And maybe I'll just make that a nested function just for simplicity. I would have if, and I'd keep an I and j pointer, like start end pointer. I'd go if end minus start plus 1 is greater than or equal to 2. I'd return true. Or if, so that's our base case, and this is not gonna cache anything actually. So yeah, okay, if that was true, then I would do that, return true, and otherwise I would check. So I'd go if si, and I'd have to go s. If sij plus 1, oops. And helper start minus, or start plus 1 and minus 1. No, other way around. N plus 1 start. No, that was correct. Then I'd go return longest palindrome. No. Then I'd return true. Otherwise, I'd return false. And let's go return helper learn as. Does this work? It'd be something like this, I think. Wait, I'm gonna just write this out real quick. Okay, so actually I asked ChatGPT, but this is actually interesting because this is similar to a backtracking problem. I can't remember exactly which one. I think it was like potentially like palindrome partitioning or something, or maybe permutations. Let me just check my solution for that real quick, because this problem, what you would have to do is actually like iterate over all possible like start and ends, and just check if is palindrome, and you can check that recursive, like is palindrome is the recursive part of this. So I guess there's like two things you consider. Is it this one? Yeah. Wait. No, not this one, not this one. I want to find it. Yeah, word search. That's what it is. So it's like there's like a recursive part, but you have to actually do that like O of n squared times. So it has like, this one I think has like really bad time complexity. I don't know exactly. Okay, m times 4 to the n, because there's 4 recursive calls, and you do it n times. But wouldn't, oh, okay, yeah. Wait, no, yeah, why aren't you doing that n squared times? M squared times. I'm not sure. Anyway, basically, interesting similarities there. And I wonder if that relates to like something, like as in like how you would know if you can actually prune this. I think I'm gonna try to compare these problems later and think about that. But yeah, interesting. I hope you enjoyed this video, and I'll definitely be posting more of these as I still have quite a few problems to get through, and I'm still also working through the Introduction to Algorithms book by CLRS. Yeah, I'll be posting more probably quite soon. Thanks for watching.